This is a video tutorial for working with Tableau Desktop and Tableau Public, and it's broken into three separate parts. The first part is acquiring data and organizing a Tableau workspace. We're going to be using USGS earthquake data, using a utility called bBoxFinder to geographically constrain that data. We're going to open up a Tableau workspace, save it, do some basic work within that space. Then we're going to move along to creating a table, discussing dimensions versus measures, creating sheets, binning, and table creation within Tableau Desktop. And then we're going to move along to working with latitude and longitude in Tableau Desktop to allow a geospatial visualization. We'll create some tooltips, do what's called proportional symbolization, actually create a field calculation, and then bring that all into a dashboard. And once it's in a dashboard, then we can upload that to Tableau Public and make it publicly accessible. So this whole video series assumes a couple things. The first thing is that you've actually downloaded the Tableau Desktop, either as a trial, as a student version, or maybe a full paid version. Either which way, Tableau Desktop, we're assuming that you have that. The second thing is Tableau Public, which requires a separate sign-in. It's free, it exists in the cloud, so it's not something that you're necessarily downloading on your desktop, but it works with Tableau Desktop in that it's a space by which to publish your completed visualizations and make them public accessible. And it allows a fair amount of space devoted to you as a user, as a signed-in user. So I think it's 10 gigabytes altogether, which is a fair amount of space. We're going to be utilizing the USGS earthquake dataset. This is a dataset that is quite expansive, and what we're going to do is subselect to a geographic region. So you can see this is the URL to actually get the data, which is earthquake.usgs.gov/earthquakes/search. And here you can set up a magnitude, a date and time, and a geographic region. We're going to utilize 2.5 magnitude as the start, past 30 days, and then we're going to tailor a geographic region. And then we're going to download that. That's going to download as comma-separated values.csv. Once that is downloaded, then we'll actually bring that into Tableau Desktop. So the first part of this video here is part one, and this is where we're actually gathering the data. And in just a few minutes here, we'll actually be opening up Tableau Desktop and starting to work within the software itself. So if you already have data, you may want to skip forward a little bit. If you're interested in just getting a data set to work with within Tableau, this is a good place to start with me right now. So the first thing we want to do is we've navigated to usgs.gov for earthquakes. And the second thing is that we want to use a utility called bBoxFinder to subselect based on location. So we know that earthquakes are active throughout the world. They're happening on a consistent basis, and the USGS data set tracks those earthquakes. And there's certainly hotspots, and one hotspot that we can use for a demo purpose is the western coastal region of South America. So in this case, I want to just set up a project area that's just going to encapsulate the western coast here. So Ecuador, Peru, Chile, these will be countries that will be within that space. So what bBoxFinder does is it allows you to simply draw a polygon, and then based on that polygon gives you back coordinate pairs that you can then put into USGS. So we're creating what's called a bounding box. And in GIS terms, this is the outer area of whatever feature you have. It could be points, polygons, lines, whatever the outer extent is of that data, that particular data set. That's what we call the bounding box. So let's go ahead and set that up. So the first thing we want to do is that in the lower right-hand corner, you're going to see a coordinate format, and there's two. There's lon versus lat, or excuse me, lon / lat, and lat / lon. We want the latitude to go first, so we're going to click on that. So it's lat / lon. And under our actual coordinates, we have two options. We have EPSG 4326, which is your standard WGS84, what's going to be on your iPhone or what's going to be in the GPS. These are geographic coordinate pairs. Then there's also the Suter-Mercator, which is used for web mapping, but actually is recorded in meters, not degrees. So we would just want to make sure that we have WGS84 clicked on here, because this is what is going to work within USGS to define our earthquake area. So what we do is we come up here to the top, and the second button down below the zoom plus and minus, you'll see a draw polygon. So what I'm going to do is I've decided what my project area is here. I'm just going to draw a polygon around it. And it doesn't have to be exact, right? Ecuador, Peru, and Chile here. And as soon as I do that, then it actually creates this black perfect rectangle based on my not perfect polygon that I drew. And it's also going to give me back now under mouse, box, map, and center certain coordinate locations. And you can see as I'm moving along, we can see our mouse changing its coordinate pairs. I'm interested in what this box says because the box is basically describing this black drawing right here, this extent. So what we're going to do is we're going to come along to the box and copy that. So we have pairings, this latitude and longitude. So first we have a latitude of minus 59. And I'm going to lop off some of the precision just to make it a little bit easier to discuss. So I'll just have 2-digit precision. Okay, so my first latitude is minus 59, and then the longitude is minus 92.04, and then I have a latitude of 4.94, and then a longitude of minus 63. So what's being described here is that down here at the bottom, I'm about 59. Okay, that's my first latitude. And then if I go up to the top here, I'm at about 4.94. That's my second pairing of latitude. And then if I come over here, minus 92 is my longitude. And as I go towards Greenwich, okay, Greenwich line is going to be the prime meridian is going to be in this area over here. I'm going towards 0, so minus 63 is going to be on this side. So we can think of it, if we think of it this way, my south is going to be the first one. My north is going to be 4.94. My west is going to be 92. And my east is going to be 63 over here. Okay, so these are the coordinate pairs that I need to then bring into USGS. So south, minus 59. And let's do north. I'll copy that out and just put that towards the top here. North is going to be 4.94. West is going to be minus 92. And east is going to be minus 63. And I don't need any more precision than that because we're not worried about large-scale mapping here. We're doing a relatively small-scale mapping. So now I'm going to come back over to Search Earthquake Catalog, and we can see if we expand advanced options here, we can see we can define a geographic region. So here I'm just going to simply go back into my document that I created here. And so for my north, I'm going to put in, let's just put in 5 to round everything out. So 5. And then south's going to be minus 59. Let's make that minus 60. And then I'm going to be west of minus 92 and east of minus 63. Okay, so that's my bounding coordinates. The event type I want to have as earthquakes. So I click on earthquakes. I'm not really interested in non-earthquakes for this particular work. The impact, I don't need to worry about the impact. The catalog, there's nothing that we're going to select out of the catalog. Contributor, it can be from any system contributing to the USGS dataset. Now the product type, I'm going to choose any. And then also for the output options, I could pick a pre-made spatial file, but in this case I want to also work with tabular format within Tableau desktop. So using CSV is going to make sense for our purposes. So I'm going to click on CSV, and I'm going to go back to the very top, and I'm going to make sure that I've clicked on magnitude of 2.5 or greater, past 30 days. I'm doing a custom geographic region that I've defined under advanced options geographic region. So I'm then going to simply say search, and output format's going to be a CSV, and it's going to download that automatically. It's going to call it query.csv. So what I'm going to do is I'm just going to bring this over to the desktop real fast, and I'll just put this in my folder. I've set up a folder called USGS Earthquake. And I'm just going to put that in here. So this is my project folder. Now what I want to do, I have my data. So actually we can preview that data. I'll preview it with a little table viewer that I have here, table tool. And let's just take a look at the attributes real quickly. So we have a time. Importantly, we have a latitude, longitude with a fair amount of scale and precision. We have a place name. So this kind of gives us a text description relative to countries, relative to cities, which is very helpful. We can see a magnitude also, which is what we're going to be working with. So under the magnitude, we can see that we have 4.9, 4.8, a lot of 4s. So we know that most of our data set is going to be just previewing it here. Looks like it's between 3 to 5. So that's going to kind of be our range of values. So they're very clustered around these kind of middling size earthquakes. Depending on your location and your time, you may have a radically different range of values than what's being previewed here. For the most part, in this demonstration, we're going to skip the other attributes. We're mainly interested in place. We're interested in magnitude. We're utilizing latitude and longitude. Okay, so that's our data. I'm just going to go ahead and open up Tableau Desktop now. So this is what it looks like when you open it up. It's going to have, depending on what you're doing and how far you've worked along, you may have some workbooks that show up here where it says open. I'm just starting from refresh right now, so I don't. And under Tableau, we can see that we don't have a lot under the main menu at the top. Okay, so the first thing I want to do is it really wants to connect to data because it needs data to actually work. So what we're going to do is we're going to connect to, here's all the different things we can connect to. We could also connect to online sources. So we can see MySQL and Tableau server. In this case, we want to just connect and go to more. And under more, we're going to point to our query CSV. And we're going to open that. And as it opens up, it gives us a preview of the data in a tabular format. And if we go down to the bottom, we can see that a sheet 1 is being created for us. Okay, let's not go there just quite yet. There's something important in this space that we need to decide off the bat, and the sooner you do it, probably the better. We can connect to a live source, or we can do what's called an extract. Okay, so with the extract, and when we save it, which we'll do in just a second, we'll be creating sort of a bundled product that works well with Tableau Public. If we're working with online data sources or going to a database, we may not be working with extract. But in this case, since we've downloaded the data and we want to bundle up a visualization for public viewing, clicking on extract makes sense. So we're going to click on extract. So the extract will include all the data that we have here. And then what we're going to do here is we're going to go to File and immediately Save As. We have two different options. We can save as Tableau Workbook, which is a little bit lighter version. Doesn't necessarily bound up the data, but we can do Tableau Package Workbook, which is TWBX, which is what we want to do. And for demonstration purposes, I'm just going to call this Book 1 and leave it as the default. You can easily rename this something. It could be my earthquake project or my first Tableau project, whatever it's going to be. And I'm sticking it into a project folder that I've called USGS Earthquake. Okay, so I go ahead and save this. So it says to save the workbook, you just either create an extract or click Clamp. So we want to create this extract. Okay, so the extract now includes all the data that we have here. So that's what we want. So we've created all the components that we need to actually start working with the data. And the first view that we have is what's called the data source view. So that's what we're looking at. We're actually looking at the table data itself. And we'll need to be accessing this throughout the series here. But what we're really wanting to do is visualize this data in some way that's not just a table. So we can't really make sense out of this right now. But what we can do is we can start working with sheets. So the first one is sheet 1. I can rename these if I want to. If I just down in the lower left-hand corner here, you can see if I wanted to rename it. We're going to be creating a table first, but I'm just going to leave it as sheet 1 right now. You're welcome to rename it if you want to. And what it does is it divides up the data into two components. The first one being what's called dimensions, the second one being what's called measures. And if you look at the naming here, and we go back to the data source, so we have an ID, locational source, bagged source. Let's go back to this. Here we can see that we have those same attributes. Here's our ID. We have magnitude type. Magnitude source is somewhere in here. Let me see if I can find it. Here it is down at the end. Okay, these particular attributes are showing up in dimensions and measures. The difference between dimensions and measures is that dimensions are looking for attributes that are discrete in nature or categorical in nature. They're telling us something specific about the data that's not continuous. It's not a continuous number. Okay, it could be a color, it could be a type. So in this case, type is definitely going to fall within the dimensions. It's earthquake, because remember when we went to USGS earthquakes, we specified that we were just interested in earthquakes. If we clicked on some of the other categories, we would see those type categories showing up here, and then under our dimensions we would also be able to access those as different types. But in this case we're just interested in earthquakes. So if we go back to sheet now, we can see that these categorical discrete values are showing up under dimensions. This is really a kind of a nice thing that Tableau does right off the bat, is that it guesses what type of values you have and organizes it across dimensions and measures. So it's really a nice way for, it's a cheat sheet to your data so that you can quickly start to work with it. So in this case, we can see what we're really interested in is earthquake magnitudes, and that's a measure because that's a continuous value. So some earthquakes are 4.9, other ones are 5.0, other ones are 5.1, 5.2. So the values are continuous in nature. They're not categorical. They're not telling us one type versus another type. Okay, let's review real quickly some of the main areas of the interface here. So we have dimensions and measures. We have marks, columns and rows. We also have a Show Me tab on the far right-hand side. Then we have our main menu at the very top. We're going to be working primarily with columns, rows, and marks, and also dimensions and measures, and then selecting out from the Show Me tab visualizations. In this case, we're going to do a text table visualization, which is probably the most fundamental visualization that we can do. If we go back to our data source and look at our magnitude, we can see that this is a continuous value. So it's going 2.9 all the way into probably the 5s, and it's doing it in a continuous nature. There isn't any categorical break. But if we want to, we can go to sheet 1, get back to our dimensions and measures, and actually create a classification of that magnitude and put it into dimensions. And the way that we do that is we'll go to Mag, and then say create, and we want to create what's called a bin. So this is organizing the data, classifying it into certain categories. So if we click on bin, we can see that it creates a new name called mag bin. So it's actually going to create a new field within our data set, and it's going to give it a certain size. So this is kind of, you can think of it, how wide is the bin to collect data within. So in this case, it's 0.351. That would be the default. It's suggesting a bin size of that size. Let's make ours just a little bit wider, so it's a little bit simpler of a classification, I guess you could say. So it's 0.5, and our maximum value is 2.9, and maximum is 5.4, minimum is 2.9. So between 2.9 and 5.4, it's going to go along and create bins with breaks of 0.5. So let's see what it does. We'll say OK. And we can see that it immediately creates a magnitude bin under dimensions. And if I go over here to data source now, we should see a mag bin at the very end. And we can see that it's done that. So I have 5s and 4s. Let's see what it looks like over here in sheet 1. So I'm just going to bring this into rows. Okay. I could also drop it into columns, but in this case, let's make a row. Okay, so we don't have any data now. It doesn't know what we're actually binning, but it does have the bins created. So that's the first part of creating this default text table. And if it's not immediately clicking in, you can go ahead and click on text table and then drag in your mag bin under rows. So we've set up our classifications. That's great. Here's the title, so we could we'll change the title at some point in time. It's just called Sheet 1 right now, which is perfectly fine. What we want to do now is we want to actually put some data in here. And we're going to do that under the Mark section. So what we really want to do is we want to take our magnitudes, that continuous value that's sitting over there in that column, and actually put it into our kind of empty classified text table here. So what we're going to do is we're going to go to magnitude and drop it in, and let's put it in over size. We can see that it actually changes the size, but the problem here is that it's summing the data. And we don't necessarily want to sum it, we just want to count. Well, at least for this visualization, we want to count. So we want to know within each one of these bins, how many records, how many earthquakes fall within that bin. So in this case, let's just do count. Okay. And under count, it's going to now have, if we do a rollover, we can see that we only have one that's at 2.5. We have another count at the 4.0 bin of 32. So that's in 31. That's where most of our data is located. Okay. We could also put this under color, and that would give us different colors. We could do it under text, and that's going to show us the text. Okay, which is kind of what I want for this visualization. I just want to know simply, within these bins that I've set up, where do most of my earthquakes fall? So in this case, obviously, 4.0 is 32, and 4.5 is 31. So most of my earthquakes are right in here. There's a couple significantly larger ones, and then there's one that's sitting way down there in the lower bin. Now I could change the bin size if I want to. If I feel like this is a little too, if the bins are too wide or too narrow, I can go back and change those. But for right now, this is exactly what I want. I just want a simple table that shows me how do all the earthquakes fall within these particular categories. So we've created our first table visualization of the data and added value. We had a sum count of 66, and it's divided those 66 earthquakes into these bins. So that's really helpful to understand our data. So I'm just going to go ahead and say File, and I'm going to save this. So what's going to happen now is that it's saving everything in the Tableau file, and it's saving the data. It's also saving anything that we've done up until this point. So if we were to walk away and open this on another machine with Tableau Desktop, it would open up perfectly fine. So I'm going to go ahead and stop this video right now. This essentially takes care of part 1 and part 2. We've gotten to the point where we've created a simple text table. And part 3 is going to develop a geospatial representation